This is a flipped video for graphing quadratics in intercept form. Quadratics are everywhere. They're even in our video games. Video game designers use parabolas to determine flight patterns of objects in motion. This includes Toad and Yoshi from the Mario video game series and the flight pattern of the Angry Birds. Other parabolas that we see in real life are from the shape of a roller coaster, or from the flight paths of a football in motion, a soccer ball tossed into the air, or the jump of a cyclist. Some important vocabulary for this lesson are listed here. A parabola is the graph of a quadratic function. We write these quadratic functions in intercept form, or y is equal to our leading coefficient a multiplied by our two factor groups x minus p and x minus q. Some properties of our leading coefficient will change the shape of our parabola. When our a is greater than 0, our graph or our parabola will open up. When a is less than 0, our parabola opens down. When our leading coefficient is greater than 1, it becomes more narrow. And when our leading coefficient is less than 1, it becomes wider. Our vertex is the lowest or the highest point of our parabola. The lowest point is called the minimum, and when it is the highest point, we call it the maximum. The axis of symmetry is the vertical line that divides our parabola down its center. So, for our first example, we are going to look at the equation y is equal to 2 times x minus 3 times x plus 1. Notice that our leading coefficient is equal to 2, or positive 2, so it is opening up. Our x-intercepts are determined by the zeros of our two factor groups, or for this graph, we have x minus 3 is equal to 0 and x plus 1 is equal to 0. So we find our two x-intercepts by solving these two equations, and that gives us our x value 3 and our x value negative 1. Our y value is the point at which we are crossing the x-intercept, or the x-axis. So our values here are always going to be 0. Our axis of symmetry is found by adding the x's of our two intercepts and then dividing them by 2. So for this problem, we have 3 minus 1, which is equal to 2. Divide the whole thing by 2, and that gives us a positive 1. So the axis of symmetry for this graph is x is equal to 1. Our vertex is then found by plugging our axis of symmetry back into our original equation, and that'll give us the y value for our vertex. So doing that, we get y is equal to 1 minus 3, which is negative 2, times, the positive 2 at the front, and then multiplied by 1 plus 1, which is 2. And that gets us a negative 8. So our y value of our vertex is negative 8. We now have 3 points to plot on our table. We have our x-intercepts, 3, 0, and negative 1, 0, and our vertex, positive 1, negative 8. Now I want to pick another point to give us a more accurate shape of our graph, and I want to do this by picking one that is further away from our vertex than the points that we currently have. Well, I want to pick one that's pretty close because I don't want to be multiplying large numbers. So I'm going to pick my x equal to 4. So if I plug that 4 then into my equation, I get y is equal to 2, 4 minus 3 is 1, and 4 plus 1 is 5. And that gives me my y value, which is 10. So now I have everything I need to begin plotting my points on my graph. So I'm going to start by drawing my axis of symmetry, which is located here at x equals 1. And then I'm going to put in my vertex located at positive 1, negative 8. Notice that that is landing right on my axis of symmetry. And then my two x-axis, or my x-intercepts, which are located at 3, 0, and negative 1, 0. The point I chose is located at 4, 10, and that is way up here. And now, to get a more accurate shape, I can use my axis of symmetry to find the point on the other side of the line of symmetry from the point that I chose. So 410 was my point, and it is located 3 to the right of my axis of symmetry. So to plot the other point, I just move 3 to the left, and that is located at negative 210. So now I have everything I need to draw my parabola, and it's going to look something like this. Note that the parabola is fairly thin since our leading coefficient was equal to a 2, which is greater than 1. So it's getting thinner. To graph the equation x squared plus 6x plus 7, we first need to get it into standard form. So to do this, I'm going to minus 7 from both sides. And that gives me x squared plus 6x minus 7 is equal to y. My next step is to get it into the intercept form. So I want to find my two factor groups, which are x minus 1, x plus 7. Though it's not written, our leading coefficient is located right here, and that is a positive 1. So our graph will be opening up. Our x-intercepts are found again by taking the zeros of my factor groups. So x minus 1 is equal to 0, or x is equal to 1, and that's then x-intercept of 0, and then x plus 7 is equal to 0, or x is equal to negative 7, 0. We find our axis of symmetry by adding these two x's and dividing them by 2, which is equal to 1 minus 7 is equal to negative 6, divided by 2, which is equal to negative 3. So my axis of symmetry is equal to x minus 3. My vertex then is going to have an x value of negative 3, and then we plug that into our original equation, which gives me negative 3 minus 1, which is negative 4, and then negative 3 plus 7, which is equal to positive 4. And that gives me a negative 16. And so I have a y value of negative 16. I now have 3 points to put on my table. I have my x-intercepts, and I have my vertex. And I'm going to pick another point. I'm going to pick this one to be equal to 2, since it is larger than my 1, 0 x-intercept. 2 plugged back into the original equation is equal to 2 minus 1, which is equal to 1. And then 2 plus 7 is 9, and that gives me 9. So the point I chose has 2, 9 as its xy values. And then my x-intercepts, my axis of symmetry is located at x is equal to negative 3. So plotting that here on my graph. And my vertex is located at 3, negative 16. Since negative 16 is a pretty large number, I'm going to count my points by 2's, so which means I'm going to move down 8 boxes, which is located then at negative 16. And then my x-intercepts are 1, 0, located over here, and 1, 0, and negative 7, 0. So that's located over here. My point that I chose is 2, 9. So that's 2 to the right, up 9. Remember, we're counting in twos, so that's about 4.5 boxes. So that was located right there. I want to plot now my last point to make our lines symmetric. So using the point I chose, 2, 9, note that I am over 1, 2, 3, 4, 5 to the right. So I want to move over this, reflect over the symmetry line 1, 2, 3, 4, 5 to the left. And that puts me here at negative 8, 9. Now I can graph my parabola as follows, and we are done. Alright, so for this equation, we have our a value is equal to 2, and since it is positive, again, it opens up. Our x-intercepts are set equal to our factor groups of x is equal to 0 and x is equal to, our x minus 4 is equal to 0. So my two x-intercepts are located at 0, 0 and 4, 0. My axis of symmetry then is found by adding those two and dividing by 2. So our two x's are 0 plus 4 is equal to 4 divided by 2 is equal to 2. So my axis of symmetry is located at x is equal to positive 2. My vertex is found by plugging my axis of symmetry back into the original equation. So I have 2 for my x value, and then y is equal to 2 times positive 2 times 2 minus 4, which is negative 2, which is equal to negative 8. So my y of my vertex is negative 8. My 3 points I can plot now are 0, 0, 4, 0, and 2, negative 8. I'm going to plot my x value of 5, and when I plug that into my original equation, I get y is equal to 2 times 5 minus 4, which is 1. And that multiplied together gives me a positive 10. So my axis of symmetry is equal to 2, and I can put that onto my graph. My vertex is at 2, negative 8, so that's located down here. And then my two x-intercepts are at 0, 0, so right on the origin, and 4, 0, so over here. I chose my point 5, 10, which is located up here. The point I chose, 5, 10, is 4 points to the right of my axis of symmetry. So if I move 4 points to the left, I am given this point here. And when I draw my parabola, it's going to look like this. Again, my a value is equal to 2. So we're looking at a pretty thin graph. Alright, so the last problem on this video is y is equal to negative x minus 2, x minus 2. It opens down because our leading coefficient is equal to negative 1, or it's negative. Our x-intercepts are found by setting them our x values equal to 0, x minus 2 equals 0, and x minus 2 is equal to 0. So x is equal to 2, and x is equal to 2. Since we have what's called a double root, we don't want to plot that same point on our graph twice. there's really no point. So when we write it down, we just write down the 1 point at 2, 0. Since this is only one value, our axis of symmetry has an x value of equal to 2. If I had added the x equals 2 and the x equals 2 together and divided them by 2, I still would have found my x equals 2. But there's no point. When there's only one x-intercept, we can just plot the same x value as we received for our intercept. So our vertex is then going to be the same number, 2, 0. And we know that because we already found that by our x-intercept. We already know our x is going to be, or our y is going to be equal to 0. So this time we are left with only one original point on our table. So what I want to do is I just want to choose a couple of points that are close to my axis of symmetry. So when I plug in 3 into my original equation, I get y is equal to negative 3 minus 2, which is equal to 1, and 3 minus 2, which is equal to 1. And that's equal to negative 1. So that gives me 3, negative 1. When I plug in the 4, I get negative 2 times 2, and that gets me negative 4. For me, that's enough, since my axis of symmetry is equal to 2, and I have chosen 2 points to the right of my axis. I am able to then use those 2 points and just reflect them across the graph. So when I have 3, negative 1, I have here, and I can reflect that 1 to the left, and that's located here at 1, negative 1, and then I have the point 4, negative 4, and that's located here. And again, that's 2 to the right, so I'll just plot this point then 2 to the left. And so now I have enough points that I can plot my graph. And my parabola is going to look like this. Notice that my graph opened down and that it is a relatively standard thickness. So to review, you graph the parabola using x-intercepts. You find those by setting our factor groups equal to 0. You find your vertex then by adding these 2 x values from our intercepts and then dividing them by 2. And then we can plot our 2 points of our x-intercepts and our vertex into the table, pick another point further away from our vertex or our axis of symmetry, and then we can use our leading coefficient to tell us whether our parabola is going to open up or it's going to open down. The axis of symmetry is going to be the line that divides our parabola down its center.